Hi, this is Dr. David Pillow, and what I'm wanting to do today is to show you how a latent variable model is estimated. And it's as simple as taking correlations and using those correlations to come up with our factor loadings. Let's jump into it. Here I have a variable, a latent variable that I'm calling authentic living. And it is a function of three measures. These items are, I always stand by what I believe in. I am always true to myself in most situations. And I think it is better to be yourself than to be popular. So we have these three items measuring authentic living. What you notice here is that this circle representing the latent construct, which is a unmeasured construct, is pointing to the measures. Why isn't it the case that if we're using the measures to form this latent construct, that the arrows don't point inward? And that is because what we do is we assume that if you are a person who is living authentically, that then causes you, leads you to stand by your beliefs, leads you to be true to yourself, to rather be yourself than to be popular. So that's our model. What we want is to get factor loadings to represent the relationship of this latent construct to these measures and basically take out the error that is unique to each one of these measures. So let me go over here and I'm going to estimate this model. Let's go over to this little button here, calculate estimates. They come up over here and I have, I believe it's a 0.75, a 0.83, and that looks like a 0.85. Where did that come from? Where did those estimates come from? That's what this video is designed to show you, to completely demystify it and show you that it's actually pretty easy to do based on the raw correlations with those few little simple tracing rules. Let's get started by showing you how I did this in Amos. Then we're going to do the algebra, and then we'll go from there to show you a few more tricks to understand this using none other than Excel. Okay, so I'm going to get rid of all this. In Amos, click on this button here, go over to File Name, find your SPSS file. Amos directly reads an SPSS file. Specify that, open it up, it shows there, you hit OK. Over here in this box, it now shows you the variables from that data set that you can use for your analysis. Our analysis that we're going to do here is a really simple one. You notice here we have draw a latent variable. We're going to take that, draw a circle, then I'm just going to click on it 1, 2, 3 times, and it gives me boxes for my measured variables and circles up here for the error term. And I want to rotate that around right. I'm going to go over here to this button, click rotate, click it once. Now it's rotated over here. And now I'm going to go to my variable list. I have 3 measures of authentic living that have already been recoded. And all I'm I'm going to do is slide those over there into those boxes. I'm going to name this Authentic Living. And I'm not going to make that 2 words because that's what I was doing before that led to a mistake. Close that. I'm going to go over here to these plugins, and it says name the unobserved variables. Click that, and it goes ahead and puts in names here, E1, E2, E3, for my 3 error terms. I'm going to go over here to Analysis Properties. Under Estimation, usually it's going to start off with Maximum Likelihood Estimation. I'm going to do Unweighted Least Squares Estimation. And then Output. For output, I've clicked Standardized Estimates. The sample moments, the implied moments. Sample moments is going to be your original correlation matrix. The implied moments is going to be your implied correlation matrix. And what's left over, the residual matrix. Got that all set. Go to this box and I calculate my estimates. Boom, the estimates are in there. And over here, I have this showing up as standardized estimates. Here's my unstandardized estimates. But I'm going to focus on the standardized estimates. Okay, in this box over here, we have our output. So I'm going to click on that. And where's it hiding? It's hiding over here. And okay, so let's take a look here. We have our notes for the model. Notice that it has 0 degrees of freedom. Here's our estimates, and there's our factor loadings, 0.75, 0.83, and 0.852. Those are standardized estimates, and that's what we're going to focus on. Or let's go to sample moments. Here's the original correlation matrix that we started off with, 0.708, 0.639, 0.624, and our model implied correlations are exactly the same. The residual correlations are absolutely 0. In other words, the original correlations that we started off with for this problem match exactly the correlations that the model has implied. Okay? Let's explore this going forward.